Hello everyone. Today I'm going to discuss the second problem of Leetcode Weekly Contest 439, which is longest palindrome subsequence after at most k operation. So what is the problem statement? We are given a string s and an integer k. So what we have to do, we can do k at most k operations. In one operation, we can replace any character in the string by its previous character or its next character. Now one thing to note is that the previous character of a is z and the next character of z is a. Now we have to find the longest palindromic subsequence after at most k operations. So let's take the first example only. A, B, C, E, D and k is 2. So A, B, C, E, D and k is 2. Okay. Now what is the optimal way to change elements? Now let's write k equals to 2 also. What is the optimal way to change element? I will write. Now let's say, sorry. So let's say we change this B to C by one operation, and we can change this D to C by one operation. After changing this two operations, changing the string with two operations, our string will be AC C E D. Now if we take this subsequence, this CC, sorry, ACC EC, okay, ACC EC. Now if we take the subsequence, this CC and this C, then the length of the longest palindromic subsequence will be 3 CCC. Okay, so this is the optimal way, and our answer is 3. Now this is the problem statement. Now we'll try to think about the possible solution. Now one uh, like basic question is longest palindromic subsequence without any operations. Okay, now how we solve that problem, and we'll try to introduce something in that. Okay, so let's solve this problem without any operations if k is 0. Okay, now let's say our entire string will be 0 to n minus 1, or we can say L to R. If we check what is the maximum length subsequence from L to R, so if SL is equals to SR, if SL equals to SR, this is the one case. If SL equals to SR, then what we can do take two elements, because the length of the subsequence will be incremented by 2. So 2 plus, we'll do recursion of L plus 1 or R minus 1 if SL equals to SR. And in other cases, what we can do, we can take two roots. One root will be L plus 1 R, because we'll just ignore the lth element. Another case will be we can just ignore the rth element, so L comma R minus 1. So there are three cases. This is the basic longest palindromic subsequence problem, which is solvable in order of n square using recursion with memorization. These are the recursion transitions. So this is solvable in order of n square. Okay, sorry, order of n square. Now let's look at the constraint, that how we can improve. Okay, now here you can see that s dot length is 200 and k is also 200. That means that let's say if we, in order of n square, if we add k here also, if we multiply this with k also, that is also possible. So order of n square into k. Okay, order of n square into k is also possible. Okay, now how will we change our recursion state? Initially our recursion state has two parameters, L and R. We'll add another parameter which will be k. Okay, L R k. Now how our recursion state will change? Okay, now if of s of L equals, if s of, if we just try to make s of L equals to s of R, if s of, we try to make s of L equals to s of R, how many operations are required? Okay, that is one important question. Okay, so let's say our s of L is A and s of R is D. Okay, now you can think that we will just increase this by 2 and increase this by 2, so this will come to C and this will come to C, but that is not the case. We will just try to reach D from A or A from D. That will be our optimal case. If we try to meet in the middle, that will be same as changing in the backward direction. Okay, so if we try to make come in the middle, this will be same as going to D to A. Okay, this will be same number of operations. So we'll try to take the difference between A to D. Here the difference between A to D is 3. Okay, A, B, C, D. Okay, three operations will be needed, but we are ignoring one case. Let's say A is, there is first character is, let's say B, and the second character is Y. In that case, the difference between these will be like 23 only, right? But we can go in the reverse direction. From B we can go to Z, and from Z we can come to Y. So there are two cases here. One is in the forward direction, another one will be in the backward direction. Okay, we have to consider two cases. So in the first case, the number of operation will be the difference between them, and in the third case the answer will be 26 minus the difference between them. 26 minus diff, and a diff. So it will be minimum of 26 minus diff and diff. Okay, the operations will be minimum of diff and 26 minus diff. Okay, so with this number of operations, let's call it O. Okay, with O number of operations, we can change S of L to S of R. So we can do 2 plus L plus 1 comma R minus 1, and we are already doing O number of operations, so we'll do L plus 1, R minus 1 and K minus O. We'll go to this recursion state, and similarly the previous recursion state will be same, L plus 1 RK and L R minus 1 K, but only change in the previous recursion state is this one only. Okay, and the rest of the part is quite straightforward. TP with memorization, recursion with memorization. So let's come to the solution. Now if L is greater than equals to R, this is the best case. If L is greater than equals to R, there could be odd link palindrome also. In that case, we'll reach some string where L equals to R, then we can take this character. Okay, so if L equals to R, we will return 1, otherwise we will return 0. And this part is for memorization. Now ch1 will be s of L minus a and ch2 will be s of R minus a, and we are changing ch1 and ch2 in such a way that ch1 is always greater than ch2. This will be for our difference. Okay, we can take absolute difference also, but here I am considering ch1 as the greater one. Okay, so difference will be minimum of difference. Ch1 minus ch2 will be 2, will be diff, and ch2 minus ch1 will be minus diff. 26 minus diff and diff will taking the minimum of these two. Okay, this will be our O. I have already explained. Now we are using initializing dp lrk as 0. Now if we have to take another condition here, if O is greater than k, then we can't go to this state. If O is greater than k, we can't go to this step. So if only k is greater than equals to O, then we go to this step. Otherwise the other steps L plus 1 rk and L r minus 1 k means that we are ignoring L here and ignoring rth character here. So this problem is quite straightforward if you know about longest palindromic subsequence problem. This is just a modification of that problem. I hope you got the explanation in the code. I will try to attach the code link in the description box. If you still have any doubt in any part of the code or explanation, you can always ask in the comment section. If you find this video helpful, please like the video, subscribe to the channel and also share among your peers. Thank you.